Next up speaking, we have Professor Maria Liakata. So Maria is a professor of natural language processing at Queen Mary's University, and she is also a Turing Award Fellow, so that's through UKRI and affiliated with the Alan Turing Institute. For the sake of this conference, we originally got in touch through Maria's engagement at Responsible AI UK. So if you haven't heard about RAI UK, I encourage you checking them out. It's a big flagship program focused on researchers, projects that put responsible AI development at the core of their research. And today what we're going to hear about, I think, is a really nice bridge from today's talks that have mostly been about algorithms, open problems, their capabilities. So Maria has very technical grounding in that, but going a little bit further towards tomorrow, the sort of potential benefits and potential harms in the application of these algorithms. And so Maria is going to talk about the socio-technical limitations of LLMs in different use cases, including medicine and law. So thank you very much for joining us, Maria. I hope I got all of that right.
Yes.
And if we can welcome her to the stage.
Thank you. I'm all wired up. Can you hear me? Yeah, great. We're very excited to have this keystone project on addressing socio-technical limitations of large language models, especially looking at the context of medical and social computing. And what I'm hoping is that sort of presenting this, it will give you an idea of how you can have impact in academic projects that actually solve real-world problems, or try to address and solve real-world problems while having innovative solutions. As many of you know, large language models have great performance. They create creative content, translate across languages, answer questions in a convincing way. However, they are known to have technical limitations such as biases, privacy leaks, poor reasoning, lack of explainability, and all of these are concerns, especially if you're working in sensitive domains like healthcare and law. And so what we want to do here is create an extensive evaluation benchmark on the one-hand side, which includes criteria, metrics, tasks for assessing the limitations of LLMs in real-world settings, and taking a responsible approach, which means that we're not just going to rely on what we think is important and the academic benchmarks that we are developing, but also working with the stakeholders to create basically, to define these sort of criteria that are important to them and operationalize them into the benchmarks. And so that's one big part of the project. And the other is actually the mitigating solutions. So the novel, innovative, well, there is innovation in the evaluation as well. I mean, an evaluation is really big at the moment in machine learning overall. But there's also sort of the bit about how do we actually improve these models in terms of the reasoning, in terms of the situational awareness, the privacy preservation. So to achieve this, it's actually a really big multidisciplinary effort. So we have investigators from co-investigators. We have 12 co-investigators from different areas. So there's people like me with an NLP background. There's people with computer vision background. We have specialists in cancer research, mental health, legal experts, people with a background with really strong work in ethics and social computing. So we cover all this sort of diverse range of expertise, and all of our investigators have worked in an interdisciplinary setting before. And this kind of multidisciplinarity is also reflected in the partners that we have on the project. So we have, as well as this being a collaboration between 4 universities, so this is Queen Mary, University of Warwick, University of Sheffield, and University of Nottingham. This is also, we bring in external partners from industry, from the public sector. So we have big conglomerates such as Microsoft and Bloomberg, and Accenture and Canon Medical involved in the project and supporting us. We have legal companies such as Mishcon de Reya, we have NHS trusts, we have NHS England, and also standards and regulatory bodies. And all of these different partners, and we are also partnering with other academic centers such as the Turing and the CDT for causality in healthcare AI, and the CDT for AI in healthcare, and the AI hub in causality for healthcare AI. And so all of these kind of different partners have a role to play in the different kinds of work streams that we've planned in the project. So what we have in terms of these kinds of work streams and what we have started doing and will be doing, we have three main use cases. So one is on multimodal medical diagnostics, where we're looking at both sort of the multimodal aspect of the diagnosis and in combination with the sort of the continuity, so the longitudinal aspect of the diagnosis. We have a use case in AI support for mental health, and here we're considering, as well as the monitoring, we're considering summarization, so how can you sort of summarize therapy sessions, social media data that people are sharing who have sort of certain conditions and are talking about them, and how could these actually augment the knowledge of the therapist about this person. Dialogue self-management, dialogue-based self-management, and a combination of sort of the monitoring and the dialogue. And finally, we have a use case support, a use case on AI legal support, which is again sort of the two main applications we're looking at are summarization, especially of things like court cases, and dialogue system for legal advice. And so in this, there's a planned work for a lot of engagement. So we're going to be having, starting from December, workshops every 3 months. We have our partners, but we're all still looking to broaden. So if you're interested, please do get in touch. So it's a great opportunity to have kind of impact in these, in both the evaluation, but also in kind of what solutions can work. So what we've been doing so far in terms of sort of the kind of the methods and evaluation side, and I'll zoom into some of these. We've been looking at synthetic data evaluation. So a benchmark, so we've heard from previous talks how important sort of is the use of synthetic data, but also how important it is to have good quality data. So we've been looking at how new ways of evaluate actually the quality of the synthetic data, and particularly sort of the work I'll talk about shortly is around synthetic data from users' language. We've been looking at evaluation methods based on natural language inference, and particularly atomic natural language inference, so kind of breaking things into sort of steps and sort of cross-evaluating. Cross-model alignment, so if you have multimodal data and you have sort of your, I guess, in this particular case, we have a language translation model, and sort of you have your sort of your chemical structure model. How do you actually bring the two in the same space? We're looking at temporally aware summarization with applications in mental health, modules for temporal reasoning, survey of reasoning limitations of large language models. So these are all sort of papers in preparation or already accepted. And then the next steps, we'll be looking at working with multimodal data sets for cancer research, explainability of LLMs, and personalized generation and monitoring, especially for dialogue. So I'll now go into a little bit more detail in terms of some of the work that we've done. So I'll talk about this evaluation framework for synthetic language data. So this is work by my student Jenny Chim, who's actually doing now an internship with NHS England. And her paper has been accepted by the Journal of Computational Linguistics and will be presented at EMNLP in November. So what we are what we're doing here is we have different strategies of generating synthetic data. So this is this can be both using LLMs, but also other strategies that include diverse paraphrasing, back translation, syntactically guided paraphrasing, and so on. So maybe taking a step back, why is this a good idea to actually create the synthetic data? So apart from the fact that we do need sort of more data for training, right? So data augmentation purposes, there's also issues around preserving quality of good annotated data. So if you have sort of small amounts of good data, how can you sort of generate more good quality data? But there's also issues around privacy preservation. So if you have data annotated, let's say, of electronic health records, or even this sort of mental health sessions or social media that where sort of vulnerability of individuals has been identified, how do you actually make sure that you sort of preserve as much as possible, not just the identity of the individuals, but sort of much more subtle data that could actually reveal information about them and who they are. So, so we have all these strategies for generating the synthetic data. And then we have sort of these intrinsic metrics that have been introduced for evaluating the quality of the data. And we've been looking particularly at aspects such as meaning preservation, style preservation, and divergence as a proxy for privacy. So with meaning preservation, you know, if you have your original data, you don't want to and it's about someone having a mental health condition, you don't want sort of your you know, your generated data to be talking about something different that will change kind of the meaning. And for example, if someone has is using has a lot of disfluencies in the way they speak, you also want to preserve that. But you don't want to make it too similar to what you have, so which is why you need the divergence. So these are kinds of, we've introduced these metrics for the intrinsic evaluation, and then we look at how actually this synthetic data affects downstream tasks. And so in this case, we look at tasks for user re-identification, so from a privacy perspective, and we also look at how this affects different kinds of downstream tasks that involve classification, but also classification at different levels of temporal granularity. So this means that you might have, let's say, tasks where you have just post-classification, so like sentence classification, or you have something more complex that is like the interaction in a dialogue, or you may have something that involves classifying longer contexts. So we have kind of these range of kinds of tasks that we basically evaluate on. And so this is just from the part of the extrinsic evaluation, showing on the left what we do about sort of the privacy. So in the privacy setup, we substitute the original data with synthetic data for training and validation, and sort of we see how that kind of affects the sort of the user re-identification. And in the augmentation setup in the right, we undersample the original data, so we take 10%, 50%, or kind of all of the original size, and then augment with equal amounts of kind of the synthetic data, and again see how that affects performance. And it's kind of you should read the paper, but just to say that sort of an important finding is that basically the change of temporal granularity also has an effect in sort of how well the kind of the synthetic data works and helps in these kinds of settings. How much time do I have? Okay, so I'll then talk about this kind of hybrid system for clinically meaningful timeline summarization. And I think why I wanted to sort of talk about this is, again, because it's bringing sort of the use of an LLM, but also with a kind of different kind of machine learning architecture, which is interesting, and then results into something that is actually a real-world solution, which is this clinically meaningful summarization of social media data that can then be used by clinicians. So this assumes that we have some kind of social media thread where people are talking, such as the ones we can find on TalkLife. This particular, we worked with all of TalkLife data, where people are sort of talking a lot about their mental health, and they have these kinds of periods of escalations and switches where kind of their mood changes and things are happening. And but these are very noisy. So you see, like, people are talking about all kinds of things, an explosion of emotions, recurring themes. It's not really something that you could say to your therapist, right, you know, here's my social media data, figure out what's going on with me. You really can't do that. So even if you wanted to give them the data. So, so here the issue is how we can actually translate these kinds of timelines into something that is actually meaningful for the therapists. So they can capture individual state of mind, but at the same time organize the information in ways that are useful for diagnostic purposes, understanding the behavior and kind of the changes that the person is undergoing. So we teamed up with clinicians who talked to us about sort of a number of aspects that would be useful to them. And so then we have kind of the, you know, our problem is, right, we have these noisy data and we have these kind of clean aspects, and we want to go from the noisy timeline to actually this kind of clean summary of what is going on. And so the way we went about solving this is by having two layers of summarization. So one was at the level of the timeline, where you essentially create a first-person summary of what is going on, and it's when we call it kind of the evidence summary. And then we translate that through instruction prompting to through an LLM into the aspects that are actually useful for the clinicians. And the first part of the system was the main technical novelty, as well as the whole concept. But the main technical novelty is actually how you actually get this from the really noisy data, this evidence-based timeline summary. And mind you, we didn't have annotated data. So this was an unsupervised approach which is using a hierarchical VAE, a variational autoencoder, to learn to reconstruct segments of this timeline and sort of connect features, important features within and between segments, and so basically create a structured latent representation that you then sort of condition the generation of sort of the actual summary on. And again, this is a paper that was presented at ACL this year, and I think my student is here if you wanted to ask them, but I can also answer questions about this if you're interested. Do I have time? No. Okay, so very quickly, we also have done some interesting work around how we inject temporality into transformers, and hoping to take this further to injecting temporality into LLMs. And this is basically based on concept of temporal rotational embeddings and temporal multi-headed attention. And this is a paper that's going to be presented at EMNLP in November, and Talia is definitely here if you want to talk to her more about this. So where are we going next? We're going to look at sort of multimodality for cancer research, explainability, personalized generation, and we are also hiring on the project and looking for partners. So do get in touch if interested.
Okay, we do now have time for a couple of questions. If anyone has one, please raise your hand up. Yeah, I think, tomorrow afternoon we have the AI and medicine session, so I'm sure a few of those would have burning questions. So we see one. Yep. Might take a little while to get up there.
Yeah, there's the gentleman. So the gentleman there had a question, but no one gave him a mic.
Hey there. So in the context,
There, okay, great.
there we go. In the context, like when you look at like architectures like convolutional neural nets or graph neural networks, you can do like data augmentation to, you know, try and get a model to generalize a lot better to certain features within the data. I know that you mentioned that you do some data augmentation within your work. In terms of like the augmentation that you do, what are you trying to get out of that augmentation? Are you trying to get a model to learn different features or generalize better to certain things?
So there's two reasons. One is privacy preservation, and the other one is, you know, because you have small amounts of data, you know, you will do better, I guess, if you have more data. So that's and especially if you have like the good quality but small data, you know, it's important to sort of then generate synthetic data that is of good quality, so that your augmentation is, you know, is useful. So that's the kind of the reasons why we're doing it.
Thank you.
Thank you. It's just a follow-up question. So if you're trying to, for example, help clinicians to diagnose patients, for example, then why couldn't you use an anonymized teleconference data? So, for example, when a patient calls his doctor, and obviously you anonymize all his personal details, but then you could use the recordings to train your data for to use the recordings or to train the model with this data, with this type of data.
We could, if we had the data set, yeah. I mean, we had a lot of, in this particular context, we had a lot of social media data, and the clinicians that we were working with were interested in sort of how do you actually make any sort of use of that. But we're also working with therapy session data. So some of what we're, some of our methods will also be looking at, yes, sort of therapy session data and progression of individuals across therapy sessions.
One more question.
Well, yes. I mean, this was I didn't actually talk about this work, but the work that the sort of the summarization stuff was based on. Prior to that, we were looking at longitudinal predictions of individuals in terms of changes in their. So rather than looking at particular diagnosis, what we were looking at was understanding when someone is changing, and so this has applicability in a lot of different areas. So it's not just around mental health, but also someone is changing opinions. You could have sort of this kind of radicalization, for example. So there's what we're doing is looking at methods for identifying changes from baseline, essentially, over time.
Okay, and so let's thank Maria again. Thank you very much for a wonderful talk. So we now have a 20-minute break, so feel free to get up, stretch your legs, get some coffee, and let's try to be back for 2:45 sharp for Professor Carl Friston's keynote. So thank you.